stressed about this job? I mean, I know I'm a genius and all, but why is it so much work?
I completely understand you, but you know, this is the kind of stuff you have to do when planning the annual HYUNLYMPICs. Hello ladies, we're pleased to be here today. My name is Albert. Nice to meet you. Nice to meet you.
My name is Jericho, and we hope you're ready to, have your minds blown, because we've got some great ideas for the stadium.
Awesome. Let's get started.
Alright, so first we have to figure out the area of the stadium, which I have here, to know how much land we're dealing with.
Area? How the heck are we supposed to find that?
Ladies, we're using the greatest tool known to mankind.
Google?
No, calculus.
For problem A, we are asked to find the area of R. To solve for the area, we are going to use integral. The problem gave us two functions, f of x and g of x. That means we are going to use the integral of the upper function minus the lower function. First, we must find our integral limits, 0 for the lower limit and 2 for the upper limit. Now we must find which function is upper and which one is lower. We can do that by plugging in any x value between our integral, from 0 to 2, either f of x or g of x. I plugged in 1 to f of x and got 0. By analyzing the graph, we can tell that f of x is the lower and g of x is the upper function. Now, we can plug in our functions from the equation upper minus the lower. We must find the antiderivatives. Then we could integrate and plug in the limits of 2 and 0 to solve for the area of R, which is 16 over pi minus 4 over 3.
Go.
Figure out the volume of the stadium in order to figure out the maximum capacity of people we can have inside.
Okay, are we still using calculus?
Of course.
Okay, for part B, we are told to rotate the region along y equals 4. The red line will represent the big radius and the smaller one, which is the orange. To find the volume, we use volume formula, which is pi integral from 0 to 2. The big radius is found by subtracting the axis and f of x, then squaring it. The smaller radius is similar, which is subtracting 4 minus g of x squared dx. And we don't have to evaluate, so we're done. Yay.
So, what if I want to cut the stadium with a lightsaber?
Why would you want to do that?
Shut up, my daddy's rich. I can do whatever I want, okay?
Okay, well in that case, we can take a square cross-section of the stadium.
How's that gonna work?
Let us show you.
Now, for part C, we have to find the cross-section of the volume with squares perpendicular to the x-axis. To find volume of a cross-section, it is volume equals integral from A to B of the area of the cross section dx, which the area of a square is side squared. Side would be g of x minus f of x. So the volume in our problem is integral 0 to 2 g of x minus f of x squared dx. And once again, we don't have to evaluate, so we are done. And that is the answer. Yay.
Is that it?
Yeah, that's it.
Awesome. That's part A.
What the? Are they in the parking lot?
What if I cut the lightsaber with
What music are we listening to?
This is a Missy.
You got it, Cheeto. Let's go, Cheeto. Let's go, Cheeto. You got this, Cheeto.
Is it worth it? Let me work it.